Hello everyone. Physics always sweet. In last session, we had a discussion on mirror equation. Now, we have a plan to discuss three things: refraction, total internal reflection, and refraction on spherical surface. Refraction. What is in by refraction? When light falls on any transparent medium, it will be transmitted. It means light passes from one medium to another medium. What about that? Optically, we have two medium, rarer medium and denser medium. Oil, denser medium. Around the oil, we have air. Air is rarer medium. Not only this pair, we can compare any two things. For example, air, water, and air, glass also. In these pair, one should be acting as a rarer medium and another one should be acting as a denser medium. You may look at this: rarer medium, denser medium, and light. If we pass the light from rarer medium to denser medium, the light never goes in a straight line. It will bend. Why? Because each medium has its own property of bending of light. This property is called refractive index. It is denoted by symbol mu or small n. In case, just imagine only one medium, air medium for example. If you pass the light within the medium, what will happen? The light will move in a straight line. It never bends because only one medium. Already we have studied about laws of reflection. In the same way, laws of refraction. The first law, incident ray, refracted ray and normal line all lie in same plane. The second law, sin I by sin r is equal to mu. I is nothing but angle of incidence and small r is nothing but angle of refraction. Sin value of this ratio is constant. This mu is refractive index. In this diagram, there are two normal lines. In this normal line, you may find out angle of incidence and angle of refraction. It means I1 R1 and I2 R2. So, this is the exact path of light from rarer medium to denser medium. You can notice incident ray and emergent ray, they are in parallel. If you want to make it clear, just extend the incident ray along its own direction. Now you can see the gap between dotted line and emergent ray. This gap is called lateral shift. Do we have experience with this lateral shift in our everyday life? Yes, absolutely. Consider a water-filled tub or mug. Place a coin at the bottom of the water. After placing, just look at the coin. Sure, it will be appear very close to our eyes. Why? Because of this lateral shift. Not only this, some interesting natural phenomena, for example, sunrise and sunset, related with this lateral shift. Advanced sunrise and delayed sunset. The sun is visible a little before the actual sunrise. Yes, we are watching the sunrise 2 minutes before. Likewise, the sun is visible 2 minutes later from the actual timing while sunset. The refractive index of air with respect to vacuum is 1.00029. Due to this, the apparent shift in the direction of the sun is by about half a degree. That's why this advanced sunrise and delayed sunset. Already we had discussed about light traveling from rarer medium to denser medium. In case if light travels from denser medium to rarer medium, what will happen? The light will be split into two parts. One part it will be refracted into another medium, and remaining part it will be reflected back in the same medium. That is called internal reflection. Now, what is meant by total internal reflection? Following diagram help us to understand about total internal reflection. In this diagram, you may look at rarer medium and denser medium, and O is the object placed inside the denser medium. Now, we are going to enter into a beautiful mechanism. Watch deeply. If the incident ray from the object travels from denser to rarer medium with the angle of incidence 0 degree, at that time angle of refraction also 0 degree. You may check about this with the normal line. You may look at the perpendicular symbol at interface of denser medium and rarer medium. Afterwards, when we increase the angle of incidence slowly, we get partly reflected ray and partly refracted ray. At this situation, you may find out angle of incidence and angle of refraction slowly increasing from 0 degree. At particular angle of incidence, we get angle of refraction 90 degree. At which angle of incidence R is equal to 90 degree, then that angle of incidence is called critical angle. Now we are in the climax of the mechanism. When we increase the angle of incidence beyond the critical angle, we can see the magic of this mechanism. What is the magic? You may check in this diagram. There is no refraction, only reflection. The entire incident ray becomes fully reflected ray. There is no refracted ray reflecting inside the denser medium. It means same side of incident ray. This is called total internal reflection. Such a beautiful incident, total internal reflection. Shall we demonstrate? Take one glass bottle filled with water and add few drops of milk or any other suspension, and take laser pointer, pass the light. When we change the angle of incidence, when we go beyond the critical angle, the beautiful magic total internal reflection will be happened. I think due to this brightness, it is not visible. Shall we enter into dark room? Hi, now you can look at the glass bottle, water filled glass bottle, and few drops of milk added. In this colloidal solution, just I am pointing the light. Now you can see the path of light. You can see the total internal reflection. See that when the light touch the interface between the two medium, we can get the full reflected inside the, yes, you can see that full reflected ray into the medium, denser medium. That is total internal reflection. Beautiful incident. I have a question. Why should we learn about total internal reflection? For this question, there are two answers. The first one, some natural phenomena based on this total internal reflection. The second one, there are a lot of applications in our everyday life due to this. Shall we go for natural phenomena? Mirage is the first phenomena. What is meant by mirage? You have experienced or seen how people and camel traveling on the desert. In the daytime, if they travel on the desert, they would have a chance to view the water on the desert. Afterwards, if they reach to that point, there will be no water. That is called mirage. Sure, I hope everyone have this experience while traveling on the road in summer days. How it is formed? It is purely based on total internal reflection. The air near to the ground becomes hotter. Above the ground becomes cooler. The hotter air is less dense. The cooler air more dense. Now look at any object, tree, building, etc. The building is in cooler air. It means denser medium. If the light travels from denser medium to rarer medium, what will happen? At a particular incident angle, total internal reflection happens. By this way, we get the image. Next, diamond. Diamonds are known for their beautiful shining. The critical angle for diamond is 24.4 degree, small angle. Therefore, once light enters into the diamond, it will undergo total internal reflection. That's why it's shining. What are the uses of total internal reflection? Optical fiber. Yes, optical fiber used to transmit audio and video signal through long distance, and it is used as a light pipe for visual examination of internal organs like esophagus, intestine, stomach. It is made up of glass or quartz. In this two-part, one core and another one cladding. Core acts as a denser medium, cladding acts as a rarer medium. Once light enters into the optical fiber, it will undergo repeated total internal reflection. In this way, optical fiber works. Next, refraction at a spherical surface. Before entering into this topic, we should remember what we have studied about lens in the previous classes. Lens. You know about lens, it has two surfaces. So, convex and even concave lens also. So, two types of lens. Lens has two surfaces. And then, if we pass the light through the lens, through the surface, what will happen? The light will be penetrating. The light will be transmitting. It means the light will be refracting from one medium to another medium. The reason, it is a transparent medium. So, it refracts the light from one medium to another medium. And then here in this topic, we are focusing only one surface, not remaining one. Only one surface. If we pass the light through this one surface, what will happen? That's all. That is the idea of this topic. If you pass the light through the lens, and particularly at this side, what will happen? But you may raise question. If you pass the light through the lens, sure the light will be transmitting this surface and this surface also. Yes. We have a next topic. In the topic, two sides. If you pass the light, what will happen on the two surface of the lens? That is next topic. Here we are focusing just one surface of the lens. And then here, why we have used convex surface? Why don't we use concave surface? We can. But in NCERT book, they have given only convex surface. That's why we have used convex surface. And then I have to tell you, this is exactly spherical surface, we have taken, in this question, we have taken very thin lens. See that this is thick, this is very thin. We have taken thin lens. Why we have taken very thin lens? Each and every part of this spherical surface act as a plane mirror. It means flat surface. We need a flat surface, then only we can derive, we can simplify this derivation. That's why we have taken very thin lens. Shall we enter into this topic? Look at the diagram. It looks like complicated but very easy. See this concave mirror surface. It means one side. That is our idea. And this line, it is called principal axis. Already we have learned. O is nothing but object and I is nothing but image. C is nothing but center of curvature. And here they didn't mention, but actually pole. So point P. And then this capital R is nothing but radius of curvature. Distance between C and pole. Center of curvature and pole. And then U is nothing but object distance. It means distance between object and pole. And then V is nothing but image distance. Distance between pole and image. And yeah, here you can see the dark line. This represents incident ray. And then this dark line represents refracted ray. And N1, N2. N is nothing but, it is a symbol for refractive index. Sometimes we will be using mu or N. So N1, N2 means there are two medium. N1 is nothing but refractive index of one medium. N2 is nothing but refractive index of another medium. Here one medium is air and another medium is transparent medium. It means glass or lens. Right. Wherever you see the incident ray and refracted ray, easily you can find out angle of incidence and angle of refraction. How? Just draw a normal line to this surface. If we draw the normal line, we may find out angle of incidence. How? Angle between normal line and the incident ray. This is called angle of incidence. And then angle between normal line, see the dotted line, normal line and refracted ray. In between there is an angle, that is angle of refraction. That's all about the diagram. What is the aim in this topic? Obtaining the relationship between U, V, R. Like U plus V is equal to R, U minus V is equal to R. Otherwise 1 by U plus 1 by V is equal to 1 by R. We don't know. Any relationship between U, V, R. We have to get the relationship. How? For this we need three steps. The first one, finding I value, angle of incidence. And next, finding R value, angle of refraction. And third one, Snell's law. If we substitute I value and R value in Snell's law, we can obtain the relationship between U, V, R. How can we find out I value? Look at the diagram. There are some triangles. NOM, NCM, NIM. And then you may find out this dotted line also. This dotted line attached with NOC. This dotted line attached with this triangle. So we can get the exterior angle. Yes, try to remember our lower class mathematics. What is the exterior angle? Angle produced between the tangent line attached with the triangle. So this is exterior angle. How can we find out the value of exterior angle? If we add the opposite to interior angle we will get the value of exterior angle. For example, I can show you, see that triangle and this is tangent line. How can you find out the exterior angle produced here? How can you find out? If we add opposite to interior angle, we can get the exterior angle. So what are the interior angle? Theta, theta. Theta plus theta is equal to 2 theta. So we can match it exactly with the diagram here. So this is the tangent line, dotted line, right? And then this is the triangle, see, NOC. So in the same way, if we add these two values, we will get this one. So NOM plus NCM. If we add these two value, we will get angle of incidence. So how can we add NOM plus NCM? See that I can tell you here, I is equal to angle NOM plus NCM. If we add these two, we will get the angle of incidence. Now, how can we find out angle NOM and NCM? It means these angles. How can we find out? For this also, we need to remember our lower class mathematics, properties of triangle. If we know the sides of the triangle, we can get the angle. Otherwise, if we know the angles, we can get the sides of triangles. We can apply this property here. The triangle NOM. In this triangle, we have a side value OM, U, and NM. We have a value because we have taken only a small part, maybe 1 millimeter or 1 centimeter. Anyway, we have a value. So we have a value, side value of this triangle. So we can easily find out this angle. Now you can raise one question. U is nothing but distance between O and P only, not O and M. Yes, this is curved surface. When we take a very small curved surface, it looks like flat surface. So from the spherical surface, we have taken very small, so this curved becomes flat surface. So this P, point P, and this M coincides with each other if we take a very small part. Now OM, U value, and NM, we have a value, so we can easily find out this angle. For this triangle, we can get the angle by using trigonometry. What is the trigonometry? You know trigonometry, try to remember our lower class, tan theta, sin theta, cos theta. Here we can get the angle of tan. Tan theta is equal to, it means tan NOM. Tan theta is equal to opposite side by adjacent side. This is the formula. Opposite, this is the angle, we need this angle. For this angle, what is the opposite side? MN. So this is the opposite side and this is the adjacent side, OM. So tan theta is equal to opposite side by adjacent side. It means NM or MN, whatever it is. Okay, opposite side by adjacent side, OM. So in the same way, NCM. Here also we can get the tan value, opposite side by adjacent side. So this is the angle, opposite side NM and NM or MN by adjacent side CM or MC. So we got the angles. Now you more raise one more question. Why tan value? Why don't you go for sin and cos? Yes. For the sin, we have a formula, opposite side by hypotenuse. And for cos also, adjacent side by hypotenuse. We don't know hypotenuse value in this triangle. In this triangle, we don't know about this side value. But we have a value for this side and this side. So that's why suitably, when we connect these two sides, we have a tan. When we apply this angle and this angle, in I is equal to NOM. See, instead of NOM, we may substitute Mn by OM. Instead of NCM, we may substitute Mn by MC. We got the I value. We can find out R value also. R is equal to NCM minus NIM. How? R, angle of refraction inside this triangle NIC. How can you get this triangle? If we subtract from this whole part minus this one, we will get this part. See, these two parts combined as a NIM. See, NCM plus NIC. These two parts combined to form a NIM. So, if we minus this part from this part, sure we will have NIC, this part. Inside this part only we can find out angle of refraction. That's why we have written NCM minus NIM. So instead of NCM, we can write Mn by MC. How? What we have done for I? Similarly, tan theta is equal to opposite side by adjacent side. So NCM. So opposite side, it means Mn by adjacent side MC minus NIM. So what is the opposite side? NM or Mn by adjacent side. The adjacent side is Mi. So we got the R value also. Now we have found value for I and R. And next, Snell's law. We have to apply this I value and R value in Snell's law. What is the Snell's law? N1 sin I is equal to N2 sin R. If we apply I value and R value in this Snell's law, we can easily obtain U, V, R, their relationship. And finally, we may modify this Snell's law into this. Why should we modify? Here you can see some changes. What is change? Here there is a sign. In this equation there is no sign value. The sign is missing. Why? If we take sign for very small angle, there will be no difference. So that's only for small angle. So sign is negligible. So instead of this one, we may convert N1 instead of sin I, N2 instead of sin R. So this is the equation. In this equation, we have to substitute I value and R value. We will obtain the relationship between U, V, R. If we apply I value and R value in Snell's law, modified Snell's law, we will get N1 by OM plus N2 by Mi is equal to N2 minus N1 by MC. Instead of OM, we can write U minus U. Why minus U? According to sign convention. Likewise, Mi plus V and MC is equal to plus R. So the plus minus sign regarding sign convention. And if we apply these value in this previous equation, we will get N2 by plus V minus N1 by U is equal to N2 minus N1 by R. So finally we obtain the relationship between U, V, R. I hope everyone enjoyed this session. Thank you so much. We will meet with the next topic, lens formula. Bye bye.